Hello and good day everyone. I hope everyone in a good condition. My name is Nurajanah binti Harun with my metric number is 140360. I am from Construction Management courses of School of HPP. In this video, I will briefly explain about a building foundation. The fundamental and the most vital aspect of the building is the building foundation. Building foundation must be sturdy enough as it will withstand the load that the building will carry on. The load will be transferred through the foundation to the hard ground or rock below the soil. Without a proper foundation, it can cause foundation failure and the building could have huge risk of collapse or other damages. The building foundation that I had chosen in this research is one of the deep type foundation. Deep foundation can be built at varying depth from 60 to 200 feet high, which equal to 20 to 65 meter. It is known as pile foundation, or specifically I would focus on ball pile foundation. Pile foundation can come with various shape and type. It is actually slender column or long cylinder that made from materials such as concrete or steel, which are used to support the structure and transfer the collected load into the hard earth. Also known as drill shaft, ball pile are reinforced concrete foundation, particularly to support massive vertical load in the structure. The pile were cast on the construction site. Ball piling is commonly used for the bridge work, tall building, and massive industrial complexes, all which require deep foundation. The piling work must be done by the ball piling contractor, since this operation requires extensive experience of piling construction and engineering, as well as the understanding of soil and also the condition of the site. The construction technique started by attaching the casting to the drilling rig. Then, the casting for borehole will be installed. Next, the borehole will be excavated and the drilling bucket will be emptied to throw out the soil and rock in the ground. Then, the installation of casting will take place and the excavation of borehole will take place. The casting will be extended. The telescopic caliber would be used to drill the borehole up to a certain depth. Then, the reinforcement that had been cast into a certain shape and diameter will be installed in the hole that has been drilled. After that, the trimming pile will be used to pour the concrete and the pile would be cast. After the casting complete, the casing will be removed and the final product of ball pile already been cast below the ground. Nevertheless, foundation failure can occur due to various reasons such as weak soil, poorly compacted fill material, slope failure, erosion, and obviously poor construction. The real case example that can be learned from is the collapse of Highland Tower condominium that located at Ulu, KELANG, Selangor. Highland Tower consists of 3 12-story buildings in the steep hill, was later extensively on the terrace in the early 1980s in western base built in stages between 1974 until 1982. Each block is named as Block 1, Block 2 and Block 3. Highland Tower collapse was caused by the instability of the pile foundation and slope failure. The engineer was not considering the horizontal load during the design foundation. Also, when the rotational retrogressive slide occur, this forward movement downhill create a surcharge load into the foundation. Since the foundation cannot resist the horizontal load, it failed and as a result, the Highland Tower collapsed. Behind the Highland Tower was a small stream of water known as East Creek. East Creek flowed into the side of Highland Tower before the construction of Highland Tower. So, a pipe system was built to divert the stream to the bypass the Highland Tower. In 1991, a new housing development project known as Bukit Antarabangsa Development Project commenced construction on the hilltop located behind the Highland Tower. The hill was clear of trees and other covering plants, exposing the soil to land erosion that is the leading factor of the causing landslide. The water from the new construction site was diverted into the existing pipe system used to divert the flow of East Creek. This overloaded the pipe system, and water, sand and silt from both East Creek and the construction site of Bukit Antarabangsa infiltrate the pipe. The pipe burst at several locations on the hill, and the surrounding soil behind Block 1 have to absorb the excessive water. The monsoon rainfall in December 1993 further worsened the situation. The water content in the soil became oversaturated to the extent that the soil have turned viscous, in effect becoming mud. By the end of November 1993, the hill slope has been saturated with water, and water was seen flowing down the hill slope and the constructed retaining wall. Shortly thereafter, a landslide took place and destroyed the constructed retaining wall. The landslide contained an estimated around 100,000 square meters of mud. The soil rammed into the foundation of Block 1, incrementally pushing it forward. After of that constant pressure, the foundation of Block 1 snapped, and in December 1963, the residents began to see cracks forming and widening on the road around the Highland Tower, a forewarning of collapse. This tragedy had caused estimated 48 fatalities. However, certain measures can be taken to counterattack this kind of failure. By report of Majlis Pembandaran Ampang Jaya in 1994, firstly, the slope gradient should not be cut very steep and should follow the requirement of slope. Cut and fill slope rubble wall around Block 1 show inadequate design and poorly administrated construction, and this should be repaired. Secondly, in terms of failure of the pipe that handle water from the hill, the pipe should be properly maintained because of the pipe was stuck and caused leakage. This leakage of water also caused the soil movement that caused the buckling and shearing of rail of the pipe foundation and also the surface runoff. Thirdly, the retaining wall is built poorly and should be repaired. The wall have very low safety factor, and the design wall would fail at 5 meter very simply, even not including the water pressure. The calculated safety factor all of those walls were which at the back of Block 1 is 1.52. Even without allowing water forces at the back of the wall should be built higher than 5 meter, calculating the water movement factor that will run out throughout the hill. It is also observed under the same study that wall composed of different stone with haphazard plaster carrying no drainage blanket over it. A disquieting point was that it had no base directly rest on the ground. The material used for the retaining wall and proper drainage should be properly built. The building foundation is instead very crucial and fundamental in order to have a safe and long-lasting building and also able to withstand hazard. Building foundation differ according to various factors, but mainly the soil condition and the type of building that would be built. Due to the failure of the foundation, it can cause serious and fatal damage, just like example of Highland Tower tragedy. In order to avoid similar tragedy from reoccurring, every party involved, either directly or indirectly, should take deep lesson by analyzing the incident in detail and make improvement, earlier preparation and also prevention steps. It is proof that the major cause of the landslide is due to the haphazardous planning in the construction of the building, such as the building structural failure. In addition, it is also implied that the negligence of safety law and act could lead to serious accident in the worsened cases. it would lead to the death of innocent people. On the other hand, the government should also enforce and monitor law that would take care of the quality of the building construction. This production of this video has been referred and credited to Mr. Farhad Ligul from International University of Malaya, Wales, for his research paper with title of Highland Tower Collapse, The Tragic Story of Malaysia. Thank you everyone for your attention. Hope we all can learn something from this video. Thank you and see you in another time. Bye bye.